Okay guys, so we're going to finish the 4.5 notes where we left off. We left off on number 12. We're going to write a flow proof for this particular problem. So the first thing we want to do is look at our givens. We are going to create a box for each given. So OS is perpendicular to PT. That's given. We also know angle 1 is congruent to angle 2, given as well. Okay, from each of those things, the next thing we want to look at is our diagram and mark some information. For example, in this one we can mark right away angle 1 congruent to angle 2. We're at a congruent statement with this piece, so we can't go any further with that just yet. We're going to come back over here and look at this piece right here. Segment OS is perpendicular to segment PT. When they're perpendicular, it means that we get right angles. So mark angle 3 and angle 4 as right angles. From there, in your flow proof, you need to say angle 3 and angle 4 are right angles. What did we have? Perpendicular lines. What did we get? Right angles. So if perpendicular, then right angles. Okay? We're still not at a congruent statement, so let's go one step further. We can say angle 3 is congruent to angle 4. The reason, if right angles, then congruent. Okay, so now we're at this congruent piece for both of those. We can't go any further just yet with those two pieces. So let's look at our diagram. We can pull out this piece right here, segment OS is congruent to itself, segment OS. Please mark that in your diagram, just like always. Because it's something that we're pulling from the diagram, we're going to put it at the same level as our givens, so off to the right of my second box. I'm going to create this third one that says OS is congruent to OS. The reason is reflexive. Okay, at this point we have enough information to say that this triangle on the left is congruent to that triangle on the right because of angle, side, angle. So create over here a new box. We're going to name our triangles. Triangle PSO is congruent to triangle TSO. The reason is angle, side, angle. Connect your boxes. This is an angle. This is another angle. There's that side. Okay, it's okay that those are out of order. Okay, we are trying to prove segment OS bisects segment PT. We still can't quite do that by CPCTC. We can, however, use CPCTC to say that segment PS is congruent to segment ST. So let's do that. The reason here, we have those triangles congruent, so the next step would be CPCTC. Corresponding parts of congruent triangles are congruent. Mark those guys in the diagram. Okay, from there, after CPCTC is used, we can absolutely go a step further. Knowing that these two segments are congruent, we can say that this segment OS bisects segment PT. You have these two congruent pieces, so that means that this segment right there is bisecting it. So continue off to the right. Here's your proof line. OS bisects PT. Here's our reason. If two congruent segments there, then bisect segment. Okay? So this is the first time that we're going beyond CPCTC. It's always used, CPCTC is always used directly after you've proven two triangles are congruent, so that you can prove any other corresponding parts are congruent. From there, you absolutely can go further and prove anything else after that if you need to. Okay, so this is the first time that we've done that. Okay, moving on to number 13. Again, we want to write a flow proof using this information. So the first thing we start with is our given. Write an individual box for each piece of given information. First piece is angle HOM is congruent to angle SOE. We know that because it's given. Right away, let's go through and mark that in our diagram. HOM, this top piece right here, is congruent to angle SOE. SOE is this top angle right there on the right. Okay. We also know that angle H is congruent to angle S. Okay, that reason is also given. Go back and mark those in your diagram as well. Angle H congruent to angle S. Make sure you mark them differently than you marked the first two angles. We're at a congruence statement with both of those. So now we are done with that. Okay, let's see if we can get something else from the diagram. Okay, from here, these two angles don't really give us a whole lot. If you look at the big triangle, this triangle HOS, do you notice that we have these two base angles congruent? Using that idea from yesterday where we said if angles then sides, we're going to go and draw that in. Okay, so make a new box coming out of that angle H and angle S, the congruence piece. We're going to say that here's our base angles, so we want their opposite sides. So across from H is OS. Across from angle O is HO. Okay, so those are the two congruent pieces. So you can say segment HO is congruent to segment OS. The reason here from yesterday, if angles, oops, that's not actually how we write it. From yesterday we wrote the little triangle symbol, the angles marked. So if angles, then sides. Okay. If you look at your diagram, we are trying to prove that triangle MOE is isosceles. MOE is this middle triangle right here. Okay. Looking, if we cover up the middle part, these two side triangles, do you notice that we have enough now to prove that they are congruent by angle, side, angle? So let's use these three pieces of information, come down here, and mark those two or say that those two triangles are congruent. So triangle HOM is congruent to triangle HOM, so two arcs SOE. The reason we said is because of angle, side, angle. We need to bring all three pieces of information down to that one box. Okay, this is where your first set of angles is proven congruent. Here's where your second set of angles is proven congruent. here's where your sides are proven congruent. Again, it's out of order on the arrows, but that's okay, as long as you have it in the correct order down here. Okay, let's look at what we were trying to prove. We were trying to prove that triangle MOE is isosceles. We need to see either some angles or some sides that are congruent in triangle MOE to say that it's isosceles. So the first thing that we can say is that segment MO is congruent to segment EO using the idea of CPCTC. So right underneath, I'm going to kind of come over this way. Segment MO is congruent to segment EO by CPCTC. Mark in your diagram that those two segments are congruent. Okay, now, if we cover up this piece right here, do you all see that we have those sides marked congruent in triangle MOE, which means that we can use the idea of those sides being congruent as isosceles, as an isosceles triangle. So off to the right some more. Let's state our prove line. We were trying to prove that that triangle is congruent. So triangle MOE is running out of space. Isosceles. You can abbreviate isosceles as ISOS if you'd like. Okay? So let's use what we know. If two sides are congruent in a triangle, then isosceles. So if two congruent sides, then isosceles triangle. Okay? Okay. Last one. Number 14 is going to require a few colored pencils. Okay, so what I would like you to do is take out some colored pencils. I'm going to use, let's go with this blue and this orange. That should be pretty good. Okay, so there are a bunch of triangles here. We have this big triangle TRP. We have this big triangle over here on the right, triangle MUH. We also have this little triangle in the middle, HIP. Okay, so let's see what we're really looking at. So hold on to those colored pencils for a minute. Let's start right at the beginning. And first thing we always do in a two-column proof, you are going to write your givens. In a two-column, remember, you can write all the givens in one line. So TP congruent to HM, TR congruent to UM, angle T congruent to angle M. Okay. Reason? Given. Alright, so there's a lot of givens that we've got going on in here. Okay, so let's just talk for a second about what these few segments are. TP and HM. TP is this whole segment right here. So because there's some overlap, I'm going to come down below and make some braces. And I'm going to say that that's congruent. So TP is that whole piece. HM, again, overlap. So this whole piece. So I'm going to start right here, go all the way down to the end, and mark it congruent on that little brace. Okay? TR and UM. Segment TR is right here, segment UM right there, so let's mark those guys congruent. And then we also know that angle T is congruent to angle M. Those guys right there. Okay, it's kind of hard to see, so this is where I'd like you to use your colored pencils. You're going to trace out the two triangles that are created with those segments that we have from the givens. So it ends up being this triangle RTP right there. And then the other one is over here. It's triangle UHM. Okay, so of course I used an orange colored pencil and an orange pen, so I'm just going to remark my diagram in a different color to help it stand out a little bit. Okay, now we can see those two triangles a little bit more clearly. Can you see in those two triangles, we have a side, an angle, and a side. Side, angle, side. We have enough just from our givens to prove that those two triangles are congruent. So right now we're going to say in step number 2, statement number 2, triangle RTP is congruent to triangle UMH. Using what we have in the diagram, side, angle, side. You do need to still write those step numbers, just like always when you prove triangles congruent. This one's pretty easy though. Where were our first set of sides proved congruent? Step 1. Where was the angles proved congruent? Step 1. Where was the second pair of sides? Also step 1. Can't really mess that part up, unless you just don't write it. Okay, we are trying to prove that triangle IHP, this little itty bitty guy in the middle here, is isosceles. So let's see what we can get. Okay, using the idea of CPCTC and the fact that we have these two triangles traced out, can you see that angle 1 is part of this big blue triangle right here, and angle 2 is part of the big orange triangle there? By CPCTC, angle 1 is congruent to angle 2. Okay? There's overlap. It makes it really difficult to see, so I'm hoping that you're using your colored pencils to help you see it more clearly. Angle 1 is congruent to angle 2 by CPCTC. Those are corresponding parts of congruent triangles, so they're congruent. Okay, we still need that this triangle is isosceles. Saying that the base angles are congruent is not quite enough. There's a step in between there that we need to pick up first before we can say that that triangle is isosceles. Okay, the definition of an isosceles triangle is two congruent sides, right? So we have these base angles now. Angle 1 and angle 2 down here are the base angle of this little triangle. So we could say that they're opposite sides. Segment IP and segment IH are congruent. Oops, in pink, that's okay. IP and IH are congruent. What did we have? We had base angles. So remember from yesterday, and actually from 2 problems ago, we said if angles, then sides, right? Okay. Now looking at this little itty bitty triangle right here, IHP, we have 2 sides congruent, which means that triangle is isosceles. So at this point, now we can say triangle IHP is isosceles. Okay, the word isosceles is on the page, so make sure that you are spelling it correctly down here, please. Alright, our reason for this, like one before, if 2 congruent sides, then isosceles triangle. Okay, that's it for this section. Make sure if you have any questions, you can come in during second hour tomorrow. Mrs. Rachel has an evening review tonight as well. Please make sure you get this stuff copied down, and you definitely can get the rest of your homework done as well.